Okay, so we're going to be using a program called codap, and we're going to be looking at different US roller coasters with their speed, height, what they're made of, and just comparing different values within this program. So here we got all of our values of US roller coasters broken up into older, recent, and newer. And then over here we got our plot of each one of our roller coasters. You can just click on it here and it'll send you right to the one you want to look at. And you just look at everything about it and just see how they stack up against each other. So first, we can just start looking at, of course everybody wants to look at speed when it comes to a roller coaster, because I mean you don't want to ride no slow roller coaster. So let's compare age group. We'll put that on our x-axis, and let's do top speed on our y-axis. Okay, so if we look, we got older, recent, and newest. So it looks like we got top speed over here. So if we look, we got 120 miles per hour as our top speed in the newest group. But if we look here in the older, we have some really, actually not really fast roller coasters at all. The fastest we have in the older section is 65, which if we look through here, we have tons that are 65, and most of these just exceed 65. So our fastest in the recent is 100. But see, we can look at it like this, but let's look at it in a more statistical standpoint. Let's look at the mean. So if we got our mean, it shows us right down the middle. So our mean for the recent is 58.1. So our average speed for a roller coaster in the recent section is 58.1. So the average for older roller coasters is 49.4. So it progressively got slower or faster as they kept building. Let's look at the newest, which is 66. So we have it looks like a pretty steady jump by roughly about 8 every time. 8 miles per hour per section of age groups. Let's look at it from a different statistical standpoint. Let's take out let's leave mean in there, look at median and see how they stack. So if we look, the median is pretty well the same with the mean on older, about 50. Those other was 49.4. The newest is about the same, 65.5 and 66, so pretty close. But here we see we got a little bit of a difference, because we can assume that's because of our outliers. We got 27 speed, and we got one way up here at 100 speed. So let's make a box plot and see how they stack up. So if we look, we got our outliers, we got our means, our outer quartile, or quartile 1 and quartile 3. So with this we can really see what the average, the median, we can just see how different roller coasters stack up. So our box plot is much smaller here because most of the roller coasters were around the same speed. Over here we have a few outliers up here at 75 or 120. And then down here at about 35. So this is a pretty widespread box plot. And then if we look here, it's a pretty small one, but we have some outliers that mess with our mean. So we can take out the mean and median, and let's look at the standard deviation. So this shows us how far we are from the mean. So our standard deviation is much larger. We have a 16.8 standard deviation of the newest roller coasters. And then here we got 11.2. And then here we have a 10.1. So after looking at this, we can see that older roller coasters were pretty much built at around the same speed, each one of them. And then here they kind of got a little different. And then here we can tell that they were building roller coasters for, we could say kids, maybe kid roller coasters down here, and then for more middle-aged or older people up here. So now we compare the age group and speed. We click right here, we can remove that from the X, and click right here, remove that from the Y. Now let's look at material, because material has probably something to do with how fast they do make these roller coasters. So we'll put the type down here, and we'll put the age group over here. And we'll pretty much just do the same thing, check our mean and our standard deviation. Let's start out with standard deviation. Let's see. It's not going to let us do it on this one. So we'll look. Let's change this around. Remove that and remove that. So let's put age group on the bottom. Let's put type on the side. Okay, so we can compare these much easier. We can see that we got wooden roller coasters were made much more older. We have very few steel, and then here we have few. I mean, it's more wooden than here. However, if we come here, it looks like it's about 3 to 4 times more steel roller coasters made. And then here we got very, very few wooden and much more steel. So we could probably conclude that steel roller coasters obviously are more faster and maybe more safe. As we progressed with our construction and engineering, we've made a lot of conjectures about steel being safer. So let's keep type in there. We'll move the age group and let's look at speed. Let's look at the speed of these. So let's look at the standard deviation. So the wooden roller coasters don't really vary in speed. The highest we got here is a 78. So, and the standard deviation is 9. So we don't have a very big standard deviation at all about how fast or slow they can make these wooden roller coasters. As we go up here to steel, we can see that there's a 15.5 standard deviation, which is much, much bigger than wooden, because we can make steel really whatever we want, because we're just so much stronger with steel. We know what we can do with it and see the progression we made. So let's take off standard deviation and look at the mean. So our average is also higher over here. We got 60.6 mean, so we got a faster speed with roller coasters that are made of steel, and then here we got a 54.5. So let's look at one more thing. Let's look at the median. So once again, we have the median's higher because we have more higher roller coasters than we do slower. And then here we got a lower mean because we have slower wooden roller coasters than we do faster. So we're going to look at this same set of data with just a new roller coaster that we've added, which is the Extreme in Baton Rouge, Louisiana. We've added every feature we can into here, and we have it right here at 45 on newer. So we can just kind of see how this varies with how it changes our median and mean. So let's throw in, what do we have over here? We have top speed at the bottom and type. So let's do type on the side, and let's do top speed, and let's do our mean on both of them. So we'll see how much it affects the mean. Alright, so we'll start with steel. We have a 60.6 mean without Extreme. Since Extreme's a steel, we don't really worry about the wooden because it's not going to change it up any. So we have a 60.4 here and a 60.6 here. So if we look here, we got our speed of the Extreme is 37.3. With that being said, it brought down our mean 0.2. So it did have an impact on our mean. Let's see if it affected anything else. Let's look at our median. So we have a 60 median. Since we did add one over here, so it's going to vary it a little bit. Let's look over here. Change our mean to median. And we have a 60. So it didn't affect our median. So we have a pretty balanced set of data for our steel. And that is us looking at this codap program using US roller coasters.